Hello, my name is Pratik Patel, and I'm a technology consultant with Ingram Micro. Additionally, I'm part of the Data Center Delta Force. This Delta Force is a team of experts assembled to get ahead of the hottest data center trends and to research and architect vendor agnostic solutions. In that regard, we can help you sell the stack, whether it's on-prem, in the cloud, or at the edge. Speaking of the edge, today I'll be discussing one of the hottest trends to revolutionize the way we think of the data center. It's edge computing. Maybe you've already heard about it being mentioned as the next step in the data center evolution, or maybe you're unclear about what it means to be at the edge or using edge computing. My plan today is to help you understand edge computing and the ways it's transforming how we enable technology. First of all, you might be thinking, why should you even care about edge computing, or why is it so important? Well, the simple fact is, edge computing is the future of computing, processing, and storage. This technology is fast growing, and according to Gartner, just a few years ago, it accounted for only 10% of enterprise data that was generated and processed outside the traditional data center, or what we refer to today as at the edge. By 2025, that number is predicted to reach an astonishing 75%. And as the Gartner quote on this page alludes to, there is a need for a solution that solves the problem of inefficiency of streaming all this information to a cloud or data center for processing. That could be the reason why there is so much excitement in edge computing. In fact, the global edge computing market was valued at approximately 3.6 billion in 2020 and is expected to increase and reach 15 billion by 2025. In a recent report by Grandview Research, that market size is expected to reach 61 billion by 2028. That's a compound annual growth rate of 38%. So you see, just these stats alone should assure you that the time you spend today learning about edge computing will be worthwhile, because this technology will have a lasting effect on the data center ecosystem. So let's start with defining what edge computing is. Gartner defines that edge computing as being part of a distributed computing topology where information processing is located close to the edge, where things and people produce or consume that information. Simply put, edge computing brings compute power outside the traditional data center and closer to where it is needed to improve response time and save bandwidth. Essentially, it's computing that takes place at the edge of corporate networks, where the edge is defined as a place where end devices access the rest of the network, say devices such as phones, laptops, and sensors. In other words, it's about solving those technology problems where the need for physical proximity to the original source of the data and the method of action is critical. For example, edge computing allows data from IoT devices to be analyzed at the edge of the network before being sent to a data center or cloud. Basically, the edge is made up of compute, network, and storage resources between devices and cloud or the data center. Edge compute can be embedded into things or separate, such as server cluster or an IoT gateway. The overall goal of edge computing is to improve user experience by processing data in real time at the edge, rather than being sent to the data center or the cloud and waiting for a response back to get a further action. In the past, edge used to be a place where devices connected so they could deliver data to, receive instructions, and even download software updates from a centrally located data center. Now, with the explosion of IoT, that model has highlighted its shortcomings. IoT devices gather so much data that the sheer volume of data requires large and more expensive connections. Moreover, the nature of the work performed by these devices is also creating a need for much faster connections between the data center or cloud and those devices. So, by putting edge computing, whether it's with video surveillance or inside autonomous vehicles, you're able to do things that used to be impossible to do before. Just because the cost of sending that data there and back was too much, or processing all of that data was too much, or the latency would allow that technology to be useful. But one thing you need to understand is that the edge is all around us. Let me explain what I mean. We often read about how everything you come in contact with throughout the day, such as your home thermostat, the coffee machine, your car, the traffic signals along the highway, the television in your living room, and the lights in your bedroom, are all connected to the internet, forming the Internet of Things. But IoT is not simply about making your life at home easier with these new gadgets. IoT is going to change the way we do business in every sector. By connecting everything, businesses will be able to optimize efficiency, increase performance, mitigate risk, and offer new services. Combined with the amalgamation of artificial intelligence and advances in connectivity such as 5G and LoRa, IoT will drive an order of magnitude of business change similar to what happened with the rise of steam power and computers. But connecting everything means that the center of gravity is shifting. Computing power and storage have already moved from physical servers to the cloud, and as we capture the physical state of the world around us, data is exploding exponentially, essentially moving the requirement of compute to the edge, where billions of devices are collecting and processing data in real time. With the shift from on-premises data storage analysis to the cloud, we saw latency issues and ever-increasing data upload and download demands, which has pushed for the need to now analyze more data at the edge. In fact, this is a key driving factor for requiring more intelligence at the edge. This means that computing needs to happen at the edge instead of the cloud to solve three types of problems: cost, physics, and regulatory. First, sending information to the cloud is expensive. Just like your cell phone data plan, both the internet provider and cloud provider charge customers for sending and processing streams of data. From the cost of perspective, computing and filtering at the edge saves bandwidth and is just more affordable than sending all the data to the data center or the cloud to be processed later. Second, for example, an autonomous vehicle that needs to stop the instant it identifies a pedestrian crossing the road can't afford the physical latency, which is the time it takes to transmit the notification to the data center or the cloud and then back to the brakes. From a physics perspective, understanding latency is key to innovating at the edge because latency is usually the limiting factor when it comes to determining whether a technology application will be usable. Lastly, locational characteristics and government regulations increasingly require that data be stored locally, not in the cloud. The fact is, more and more countries are tightening their borders and implementing new data privacy laws, such as California's CCPA or European Union's GDPR, restricting data flow across borders and thereby making edge computing necessary. From a regulatory perspective, non-compliance is not really an option because non-compliance comes with heavy fines and future restrictions. So that should give you an understanding of the key drivers for edge computing. However, to understand edge computing, you need to understand the road that led us there. In the beginning, we started with on-prem data center that was a group of servers which we privately owned and controlled. For example, servers living in a room or a section of an organization's own business infrastructure. From there, we migrated to a colo facility model, where co-location was the practice of renting space to house our privately owned server and network equipment in third-party data centers. This model offered us cost savings because of the shared resources at the facility. Of course, this was a natural progression to the cloud model, where the cloud provider managed our server, storage, and networking elements, which cut CapEx and OpEx. But realizing that data is distributed across multiple locations with different user bases, value, and context for the business, that led us to understand two things. First, that data lives across the organization, and second, that data management is even more critical to an organization. All these steps have led us to edge computing. So the question becomes, do you co-locate your compute where the center of gravity for your data lives, or do you move your data into the box where the compute lives? The short answer is it depends. While the long answer is more intriguing in that the drive to the edge shows there's power in realizing when and where it makes sense for customers to co-locate their compute to where their center of gravity for their data lives, rather than moving all their data up, out, and into the systems and clouds where the main compute lives. The great thing about cloud computing is that there are a lot of use cases that we are utilizing today. So let's look at a couple of them to help us understand how edge computing is changing the world. For example, in autonomous vehicles, how this works is that there are sensors in these vehicles that collect data and make decisions autonomously. Even on non-autonomous vehicles that you can buy today, there are sensors such as lane departure and collision avoidance systems. For example, there are backup sensors that when you're backing up will notify you or even stop the vehicle if you're getting too close to something. If you use this example to take it a step further and think about the autonomous world, you're going to need to have a lot more of those sensors in autonomous vehicles. But for those sensors to provide any value, they need to have computing resources which can process the information that's coming in at real time and take appropriate actions in real time. So the way I think of it, it's a necessity to have edge computing built into the autonomous vehicle, which can help ensure that the vehicle is getting the updates it needs so it can operate safely and properly for everyone in and around the vehicle. Let's look at another example. For example, a valve sensor at a oil refinery detects dangerously high pressure in the pipes. Shutoffs must be triggered as soon as possible. And if that analysis of that pressure data is taking place at a distant processing center, then the automatic shutoff instructions may come too late. But with processing power placed locally at the end device, latency is diminished, and as the round trip time is significantly reduced, this can potentially lead to savings in terms of downtime, damage to property, and even lives. A complete, robust edge computing environment often requires a go-to-market multi-vendor strategy, including combinations of core vendors and complementary vendors. Here's a list of some of the vendors that perform well in the edge computing practice. Along with these vendors, there are numerous emerging vendors that are helping to shape the edge computing market. So I advise you to reach out to the Data Center Delta Force for help with navigating the landscape. Hopefully, this discussion has motivated you to learn more and take action, because the way I see it, now is the time to get ahead of edge computing technology. Because edge computing is more than just a server form factor. Edge is about solving those technology problems where the need for physical proximity to the source of the data and the method of action is critical. In fact, edge is the new battleground, and customers that provide a physical product or service to their employees or customers or consumers that interact in real time is an opportunity for an edge discussion. All edge platforms generate, process, store, and forward data, and as we all know, data powers business. Any customer talking about edge is an opportunity to engage them and advise them on topics such as IoT, data analytics, or artificial intelligence. This is where I believe edge computing opportunities are going to be driven less by speeds and feeds and more by remote manageability, physical constraints, network constraints, and cloud and ISV interoperability. And finally, many of the biggest trends in technology today, the edge computing will be a necessity for each and every one of them. So when you think of the opportunities that lie ahead from all those new and exciting trends, I know edge computing is going to play a pivotal role, because edge computing delivers the necessary infrastructure solutions where it needs. But not to worry, the technology landscape is becoming increasingly complicated, but you have the Data Center Delta Force to help simplify it for you. For more information on edge computing or to have a conversation with one of our industry experts, please reach out to us at data-thecenter@ingrammicro.com. Thank you for your time.